Hello, in this part I will describe to you about tree diagram and also the use of tree diagram in solving probability problems. Beside that, also the use of the Bayes theorem formula. So let's just start with the case below. Here we have Christine has always been weak in mathematics based on her performance prior to the final exam in calculus. There is 40%, okay, there is 40% chance that she will fail if she does not have tutor. So here we have events fail exam and not have tutor. Let us define this as event A and this as event B. And it is said that there is 40% chance that she will fail if she does not have tutor. So we can say that this is a conditional probability that she will fail if, fail if she does not have tutor. So we can say that not having tutor is the prior probability, and this is 40%. And the second information is with a tutor, probability of failing decreased to 10%. So if B is not have tutor, then let's define B complement as have tutor. And then failing decrease. So failing, so we can say that P fail after having tutor decrease into 10%. There's only a 50% chance that she will find a tutor. So we can say that finding a tutor, having a tutor, the probability P complement is 50%. Now the question is A. What is the probability that Christine fails the course? Fail is PA. So let's start to find PA first. For answering the problem, let us construct a tree diagram first. So we start with the condition of the prior probability is having a tutor. So starting from a tree diagram, we have an origin and make a branch to define the prior probability, which is not have tutor, B, and have tutor, B complement. And having a tutor, the probability of failing an exam and not failing an exam. Having a tutor, probability failing an exam and not failing an exam. Based on the information from the problem we have, we know that the probability to have a tutor is 50%. So we can write here 50%. If probability of having a tutor is 50%, then not having a tutor is just 1 minus 50%. That is 50%. And this is, so we can call this as this part, the first branch is prior probability. There's also another term. In tree diagram, it is usually called as marginal probability. Now, and for the next one, let's just use the black one. This is the conditional probability. Or in Bayes' theorem, it is called as posterior probability. And from the problem, we know that A after B is 40%. And so this is automatically would be 60%. And fail with tutor is 10%. And not fail with tutor, of course, is the rest, 90%. And the product of prior probability and conditional probability, we know it will be the joint probability. So it will be P A joint B I also, because we have A and A complement, B and B complement. So here we have the joint probability of A and B failing and not having a tutor. The joint probability would be 0.5 times 0.4 is 0.2. 0.6 times 0.5 is 0.3. 0.10 times 0.5 is 0.05. And 0.9 times 0.5 is 0.45. And let us define this as the joint probability P, A, and B, fail and not having tutor, not fail and not having tutor, fail not with a tutor, and not fail and having a tutor. So this is the joint probability of the two events. Now let us solve the first question. What is the probability that she fails? We can use the total probability formula. That is PA and B plus PA and B complement, because we are looking for failing, yeah? We know from the tree diagram, PA and B is 0.2, PA and B complement is 0.5. So this would be 0.2 plus 0.05 is just 0.25. So we can say the probability of failing is 25%. One last note about the T diagram is the total of all this joint probability should be equal to 1. 0.45 times plus 0.05 is 0.5. 0.3 plus 0.2 is equal to 1. So our calculation is correct. Now from the conditional probability, these two are mutually exclusive. So it should equal to 1, and this should equal to 1. And this 2 also has equal to 1. That's how to check your calculation.